You read the title. I made my own RGB panel. It's USB powered, and it was a pretty interesting experience. But I want to take it to the next level, so I'm starting a video series. And that's because I want to make a LED panel that's as good or even better than some of the things that are already on the market. I know, it's a pretty big goal. And to do that, I first have to tell you the story about my first LED panel. For any kind of LED project, you will need three basic things: some LEDs, a way to power them, and a way to control the color and power output. And the limiting factor for me was the powering part. I wanted my first project to be powered by this power bank so I can take it with me and have some fun with RGB lights outside. It's either that or I was brainwashed by the European Union, who requires every portable device to be powered by USB-C. But that's it, USB-C power, and that meant 5 volts. The cool thing with 5 volts LEDs is that you can buy this 16 by 16 LEDs panel that are really easy to work with. They are small, light, the LEDs are super dense, and you don't have to worry when you press fit them into a 3D printed enclosure because they come on a flexible PCB. And as you can guess, I bought mine off AliExpress. Just a few bucks, you have it on the screen right now, and there's gonna be a link in the description right next to the like and subscribe button. And I waited around 2 weeks for them to arrive. And in that very order, I also got some USB-C plugs and this ESP32, which are some small microcontrollers that can control entire rows of RGB strips with a bit of code that smarter people on the web are developing, and all you have to do as the user is plug it into a computer, upload the code to the board, and then you're good to go. And even the wiring is pretty simple. I had to solder the red wire to the 5V pad, the black one to the ground, and 3 more wires going to the ESP32. And I know that's a horrible soldering job. I'm still learning, and this is supposed to be a photography light, so I need to be able to mount it to a light stand. So all that was left to do is 3D print an enclosure with a tripod screw hole on the bottom and a USB-C hole so I can power the entire thing. And it was actually working. As you can see here, it's powering on, and I even 3D printed a plastic diffuser that's just a simple cap. So I would get nicer light coming out of it. And now that the light is diffused, I can use my phone to change colors or increase its brightness, you know, the usual RGB stuff. But that's not all. Here's the really cool part. I can actually use my phone and create 2 separate groups and assign different colors and different power outputs to each one of them. Like you see it behind me, half of the panel is pink and the other one is blue. And this can be used to simulate practicals or neon signs, and it can also be used with larger lights, like this LED strip right here, where you can split it in half and have one half illuminate a side of the face and the other one the other half with different colors. Like in this photo right here, where I was using just 2 LED strips, and check out how many colors I was able to get out of them. And that's pretty much the story of my first LED project, and the story of my first fuck up, because I was massively underpowering those LED with my little USB-C plug. I wasn't aware of how the USB-C PD power standard works, or literally anything about power. But it's time to learn. When manufacturers talk about the power of an LED panel, you usually see stuff like watts. Watts is actually not a measurement of light, but a measurement of current. The amount of current that the LEDs are drawing at maximum power from the battery or the power source. And to get this, you multiply the voltage at which the LEDs are running with the amount of amps that they are drawing from the power source. So now let's run the math for my first LED panel over here. 16 by 16 LEDs means 256 LEDs. Each one of them can draw up to 60 milliamps according to ChatGPT, and if we multiply that with the number of LEDs and with 5 volts, we get roughly 77 watts. So my DIY panel should be super bright, but it's not, because I'm powering it with this silly plug right here that can only draw 1 amp. And guess what? 1 amp at 5 volts equals 5 watts. And my panel needs 77 watts at full brightness and emitting white light where red, green, and blue channels are all active at the same time, but regardless, this was holding me back. And that's not even all, because this is a dumb USB-C plug. It doesn't have USB-C PD, which is a power standard, and you need that in order to use a power brick with USB-C to USB-C cable or any of the USB-C plugs on my power bank. So I wasn't even able to power my panel with anything but a USB-A to USB-C cable and with very little power. And that's not even all, because you can't expect wires to be able to deliver 5 volts at a ton of watts. That's not how reality works. You would melt everything and you'd probably start a fire. But I didn't know that at the moment, so I was happy that I could get these PCBs that can tell the power source that it needs 5 volts and it will actually draw more than 1 amp, which is the normal rating for a dumb USB-C. The good news is that on AliExpress the USB-C PD circuits are rather cheap and you can get them like this or like this and many other shapes. And I was able to install one of them in my panel, and at the moment this thing is running at 15 watts or even a bit more depending on the charger that I'm using or the battery bank, because this is a decent battery power bank and I'm able to get 3 times more light out of my panel. Still not the maximum output that would be possible, but I think that if I manage to get there, I would also have to deal with a lot of heat. And I'm not really ready to deal with that right now. The same way, I don't think you are ready to hear me ramble about one more of my problems with this panel, because there are a few more, especially the color accuracy, but that's the topic for the next video. If you enjoyed this one and you learned something new, make sure to hit the button and check out my website where I sell Lightroom tools and presets. That was it for today. I hope you learned something and I'll see you in the next video.